Welcome to Business Statistics. Today's lecture is about dispersion measure. We will learn what type of dispersion measures are there and why we study dispersion, why it is important to study dispersion. We will learn how to compute and interpret range, mean deviation, variance, and standard deviation. All these are different types of dispersion measurements. Similarly, we will understand the characteristics, uses, advantages, and disadvantages of each measure of dispersion. And in the end, we will talk about Chebyshev theorem and the empirical rule related to the set of observation. Let's start our discussion about dispersion. Why we study dispersion? In previous lectures, you have learned about the measurements of central tendency. We learned that when we need to summarize our data, we have central tendency measures like mean, median, mode, geometric mean, weighted average, or weighted mean. All these measures describe the central position of the data, like describe the center of the data. But they do not tell us anything about the spread of data. Like, for example, if we have a data about the age of 5 students and mean age of those students is 20 years, we know the mean is 20 years, but we don't know the exact or actual values. Like when we calculate mean, we lost the original values. So how dispersion helps us? Dispersion tells us about the idea about the spread of actual values, how far actual values are from this mean. For example, as I told you, there are 5 students, one have age of 17, one have 22, one have 19, one have 20, one have 21, and if the mean is 20 or 19, this mean is not telling us about the spread, like how far actual values are from this mean. So to understand to understand the spread of actual values, we need to learn dispersion. There is a very important and interesting example. If you want to cross a river and someone told you the average depth of the river is 3 feet, and you need to cross that river by foot, do you need some additional information for that? 3 feet is nothing for you. You can easily cross that river. But if you have in-depth knowledge of statistics, you must want to know about the variation in the depth. For example, if the variation is average is 3, but somewhere the depth is more than 8 feet or 10 feet, and somewhere the depth is about 1 feet, 1.5 feet, and average depth would be 3 feet, and average depth is 3 feet. So in that case, if you try to cross that river without having the additional information on the variation of. If you see the Hammond iron works, uh, the mean for this data is 4.9 years, which shows that like there are some employees and the mean of the mean years of their service, average year of their service is 4.9 years. But if you look at the data, if you look at these bars, you can see some of the employees have more than 20 years of service. Some of the employees have more than 13 or 14 years of service. Some have more than 15 years of service. Some have about 10 years of service, 8 years of service. But the mean is 4.9 years. We can say that this mean is not a true representative of this type of data, or this mean 4.9 is not a very good representative of the years of service of employees at this organization. So this is why we study dispersion. The reason dispersion tells us how accurate is our mean and what is the dispersion or spread of actual data from the mean, so that we understand that
how we compare two distributions. Like here, you can see in Boston Rogue, the production. This example is about daily production, hourly production of computer at these two plants. Now look at this first plant, that is Barton Rogue. The average, the hourly production is ranging from 48 hours per 48 computers per hour to 52 assemblies per hour. Like sometimes they produce 48 computers, sometimes they assemble 49 computers, sometimes they assemble 50 computers, sometimes they assemble 51 computers, and sometimes 52. Like around these ranges, they are assembling every hour. Now look at the hourly assembly at Tucson. They are assembling 40 computers in some hour. They are assembling 47 computers in some hour. They are assembling 50, 53, and 60. If you look at both, the mean is same, 50. Mean for Botan Rogue, mean hourly assembly of computer is 50 computers per hour. And for this Tucson, it is same 50 assemblies per hour. But if you look at the actual production, sometimes they are producing 40 computers, sometimes 47, sometimes 50, sometimes 53, and sometimes 60. But if you look at the bottom row, they are producing sometime 48, sometime 49, sometime 50, sometime 51, and sometime 52. So if you look at the spread of the actual hourly production, you can say that Botan Rock has more, their range is small, so they have less dispersion. And Tucson, its range is large, they are producing their data is more dispersed, or their hourly production is more dispersed. There are so many ups and downs ups and downs in their hourly production. So this is why we study dispersion, just to understand what is the position of actual data, what is the mean, and how well mean is representing this data, that data, any data. Now we talk about measures of dispersion. What are different measures of dispersion? Here you can see there are three main measures of dispersion. One is known as range, the other one is mean deviation, and the last one is variance and standard deviation. Now we will discuss all these measures of dispersion with the help of examples. The formula or the mathematical equation to calculate range is we subtract smallest value from largest value and then we find out the range. Other one is mean deviation. It is represented by MD and we calculate is, you can see this is sum of absolute, these two lines shows absolute values x minus x bar represents the mean. We will subtract mean from each value. X is the value, and I will show this with an example, and you will get some better understanding with this concept. And we will divide the sum of x minus x bar with n. N is number of observation. The third one is variance and standard deviation. It is sigma square variance. Simple variance is calculated by sigma square, that is equal to sum of x minus mu. Mu is the population mean. So x minus population mean, actually this is mean. So x minus mean square divided by number of values. And how we calculate standard deviation? We just take an under root of this formula and we can get the standard deviation. Now I will explain all these measure of dispersion by example. How we calculate range.
Now let me explain the first measurement of dispersion, that is range, by an example. A branch of Starbucks selling cappuccino in 5 consecutive days in last year were 20, 40, 50, 60 and 80. First day they have sold 20 coffees, second day they have sold 40 coffees, third day they have sold 50 coffees, fourth day they have sold 60, and fifth day they have sold 80 coffees. So we need to find out the range of this data. How we will calculate the range? We will subtract lowest value from highest value. So highest number of coffee sold in each day is, in a day, is 80. So 80 minus lowest value, that is 20, 60. This tells us that the range between they sold coffees are 60 coffees. The range is 60. From 20 to 80, the range is from 20 to 80, the range is 60. This is how we find out the range of any data that we have in hand. The other example is the other level of measure of dispersion is mean deviation. Mean means average. Deviation means dispersion. On average, values, how much values are spread from the mean. The way to find out this data, the same example, what we will do, as we have learned in previous slide, that the formula to find out deviation, mean deviation, is x minus x bar divided by n. X is value, each value that we have, or each number of observation in our data. Here number of observations are 20, 40, 50, 60 and 80. So we have 5 observations, 20, 40. This one observation is x. This is x1, 20 is x1. We can denote it by x1. 40 is x2, 50 is x3, 60 is x4, and 80 is x5. So what we need to do? First, we need to find out the mean for these values. How we find out the mean? Sum of all the values divided by number of values. So the mean for this data is 50. Then we need to subtract each observation from mean, x minus x bar. So 20 minus 50 minus 30, 40 minus 50 minus 10, 50 minus 50, 0, 60 minus 50, 10, 80 minus 50, 30. And you can see that when we will have sum of these values. Now you can see there are some negative values. For negative values, in formula we have absolute, the word absolute. Absolute converts the negative values into positive. If we don't use this absolute, we will not able to find out, actually we will not able to calculate mean deviation, because the deviation from the mean always, sum of the deviation from the mean always 0. So we took absolute of each value, each deviation. 30 will become 30, minus 30 will become positive 30, and minus 10 will become positive 10, and all remaining values are already positive. So we will take sum of these values, that is 80. We will put it in the formula that we already learned. 80 divided by 5 is equal to 16. So on average 16 cup of coffees is dispersed from the mean. If the mean is 50, we can say that they have their sale for each day is 16 cup above or below the mean. So this is dispersion. This is how we found that like what the actual values, how far the actual values are, how distant the actual values are from the mean. So we can say that the actual values are on average actual values are 16 cups far from the mean. The mean is 50. Now comes with variance and standard deviation. Here's another example for this. The number of traffic citations issued during the last 5 months in Beaufort County, South Carolina. The one is 38, 26, 13, 41, and 22. So what is the population variance? How we will find out? Number one, what are the observations? X, 38, 26, 13, 41, and 22. Sum of these values is 140. Other one is, now we have to find out deviation. So how we find out deviation? We will subtract population mean from each observation. 38 minus, first we need to find out the mean. What is the mean here? We will calculate, or we will sum all these values, that is 140, divide by 1, 2, 3, 4, 5. So the remaining would be your mean. Now x minus population mean. Here is positive 10, negative 2, negative 15, plus 13, minus 6. Now we will take square of these values. The reason to take square is again negative values, that negative deviations, because some of the values are lower than the mean, they are lesser than the mean. That's why we got negative deviations. So we took square of each deviation, and then we take and now we took the sum of all these deviations. Now we put in the sample. Sum of x over m is equal to 145. Sorry, this is mean actually. Now we calculate variance. Variance is sum of deviation square, sum of deviations from the mean square divided by number of values. So sum of the deviation is 534 that we already measured through these deviation by summing by taking a sum of these deviations. So 534 divided by 5 is equal to 106.8. So here you can see there is a huge difference between deviation and mean value. So you can see mean value is 28, but the deviation is 106. That is variance. Not deviation. That is 106. This is we called. If we want to interpret this variance, we can interpret it like this. Because these are squared, so we can say it's squared deviation. Squared because the value is squared over here. Variance is a square of value, square of the variance. So squared deviation is 106, but we cannot explain this variance or we cannot interpret this value. To make it interpretable, we need to find out standard deviation. So another example of this is here. That is also the example of sample variance. That is, we have a sample of 4 values: 12, 20, 16, 18, and 19. And here is the same way to measure variance. Now, to find out standard deviation, we need to take an under root of this value, and here in this example we need to take under root of this value. When we took under root of this variance, we will get standard deviation, and standard deviation is the value which we can interpret. We can say standardly values are deviating from the mean are this one after taking under root of this 10. Square root, after taking square root of this value. Now, and a very important theorem that we use to explain deviation values. This theorem is known as Chebyshev theorem. This theorem states that for any set of observations, sample or population, the proportion of values that lie within k standard deviation of the mean is at least 1 minus 1 over k square, where k is any constant greater than 1. Let me explain you with an example. For example, we have a data that has a mean of 51.54 and the standard deviation is 7.51. Mean value is 51.54, standard deviation is 7.51. It explains that the actual values, they are 7.51 point far from 51.54. Could be greater or could be lesser than this. So by Chebyshev theorem, we can find out how many percentage of values lies by using the mean and standard deviation, combination of mean and standard deviation in this formula, 1 minus 1 over k square. Like if we put 3.5 standard deviation, like 7.5 plus 7.5 is 1 standard deviation. So if we add this standard deviation 3.5 times, so 3.5 times standard deviation square, the answer would be 0.92. 3.5 square is 12.25. It shows that if we go 3.5 standard deviation above this mean and below this mean. Let me explain you with an example. Let me take a whiteboard here. Look, mean value is 51.54. If what percent of values lie within plus 3.5 standard deviation and minus 3.5 standard deviation, plus 3.5 SD and minus 3.5 SD. If we look at the formula is 1 minus 1 over k square. That would be equal to 1 minus 1 over 3.5 square, and this would be equal to 0.92. Okay, where did we got, how we did got this 3.5? There is no specific rule for this 3.5. If we want to know how many values are lie plus and minus of 3, instead of 3.5 we can say 1.5, or we can say 2, or we can say 2.5, or we can say 3. We can find out percentage of observation using any number of standard deviation. What we need to do, we just need to take times standard deviation. So 3.5 is, we have find out the answer that 92% of the values are lies if we plus 3.5 standard deviation and minus 3.5 standard deviation. Our standard deviation in this case, SD, was equal to 7.51. So if we add up 7.5 3 times in this mean, what would be the value here? So if we multiply, what is our standard deviation? 3.5, and our standard deviation is, we need to take a bracket over here because we are going to multiply this with 3.5. So 3.5 standard deviation is 7.5, and this would be 22.5. Let me take an eraser over here, and mean is 51.54. And here also, if we subtract 3.5 times standard deviation, that is the same 7.5 into 3.5. So the value would be 22.5. So if we subtract 22.5 from the mean value and one time, and if we add up 22.5 in 51 51.54. So if we add up this value into 51.54, this would be 74.04. And the other range is, if we subtract this 22.5 from 51.54, so the value would be 29.04. 29.04. What this Chebyshev theorem told us, this Chebyshev theorem told us, if we add up the answer, if you remember that what I showed you on the slide, it was the answer of that calculation, that 1 minus 1 over k square, and on the place of k we put 3.5. The answer was 0.92. This shows that for this mean and for this standard deviation, if we add up 3 times standard deviation and we subtract 3 times standard deviation from